Okay, so here is the next one. So try to solve this one. It says, what is the velocity of a 35 kilogram mass that has a momentum of 0.6 kilograms meter per second? So go ahead and pause, try to solve this word problem, and when you're ready, unpause. Alright, so let's see how to solve this. You have 35 kg, which is kilograms or mass, and 0.76 kilogram meter per second, so that's the momentum, and we want the velocity. So this is just a simple equation. Momentum is equal to mass times velocity. So velocity is going to be momentum over mass, so that's going to be equal to 0.76 divided by 35, and that will give you 0.022 meters per second. Alright, so let's try to solve this one. It says you have a 12 kilogram mass collides with an 87 kilogram mass. Before the collision, the larger mass is moving forwards at 55 meters per second. After the collision, the combined masses are moving backwards at 33 meters per second. What is the initial velocity of the smaller mass? So this is an inelastic collision where the two objects collide and stick together. So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's write down the givens. There's a 12 kilograms, that's mass. And there's a 87 kilograms, that's another mass. And then there's a 55 meters per second, that's a velocity. And there's a 33 meters per second, that's another velocity. And let's see here, and we're trying to get another velocity. So let's just see what's happening here. So there's a collision, so there's going to be a before and an after. So before the collision, so you have two masses. Mass 1 is 12, let's just say mass 2 is 87. So mass 1, the larger mass, this says that the larger mass is moving forwards at 55, so this is actually going to be mass 2 that's moving forwards with V2 initial. So the 55 is going to correspond to V2 initial. And let's see what else here. Well, there's going to be mass 1. So they're going to collide and stick. So mass 1 is going to be moving with the velocity. Let's just wait to fill in the gaps about what this is doing. But if you read on it, says the combined masses move backwards with the final velocity of 33 meters per second. So after the collision, they collide and stick. So this is mass 1 and mass 2, and they're moving together with a combined final velocity of 3 meters per second. So the total mass is moving with the final velocity of 33. So the 33 is actually the final velocity of all of the objects. So what the question is asking is, what is the speed of mass 1 before the collision? So we're trying to find V1 initial. Alright, so here this is inelastic collision, so we have to use this equation. Momentum or mass 1 multiplied by velocity 1 before the collision plus mass 2 multiplied by velocity 2 before the collision is going to equal the total mass multiplied by the common velocity of both objects after the collision. And one more thing, let's see here. Backwards, yes. So there's one more term we have to look at, is that it's moving backwards after the collision. So here then the 33 should be negative because it's backwards. Okay, so now we can apply it to this equation. So we can just plug in what we have. Mass 1 is 12. We're trying to find its velocity, V1 initial. Mass 2 is 87. Its initial velocity is 55. And that's going to equal the total mass, so 12 plus 87, and multiplied by the final velocity, which is 33 backwards, so a negative 33. And here, this is just algebra. When you solve for the initial velocity, v1 initial, you'll get that it's going to equal, let's see here, 12 plus 87 times a negative 33, and then bring this term to the other side. It's going to be minus 87 times 55, and then divided by 12. And when you do that calculation, the initial velocity for mass 1 should be minus 671 meters per second.